Hello guys, welcome to Algorithms Made Easy. Today we will be discussing the question can place flowers. In this question we are given a long flower bed in which some of the plots are planted and some are not. However, flowers cannot be planted in adjacent plots. So we are given an integer array flower bed containing zeros and ones where 0 means empty and 1 means not empty. And an integer n. Return if n new flowers can be planted in the flower bed without violating the no adjacent flower rule. In the first example, as we can see, there are 2 flowers planted in the flower bed of 5 and we can plant 1 flower at this third position and so the output becomes true. In the same flower bed, we cannot plant 2 flowers, so we return false. Given the constraint with the question, let's see how we can solve this question. Suppose this is the flower bed given to us. Let's forget about how many flowers we can plant into this and we'll find the maximum number of flowers that we can plant. So in order to find that, what we can do is, if we see this visually, we can say that there are 2 flowers planted in the flower bed of 7 flowers. So we need to iterate over all the flower bed and we need to focus our attention on the fact where we can plant the flowers. The possibility of place where we can plant the flower. The flower can only be planted in a place where there is no flower yet. So we need to search for position where the value is 0. We'll start from the first index and we'll move till we find a value which is 0. So we find a place which do not have any flower. Now the condition says there should not be any flower adjacent to this flower. So in order to place a flower in this place, we need to make sure that there are no flowers adjacent to it. So we need to check these 2 positions, the previous position and the next position. As we can see, a flower exists in the previous position. We cannot plant flower at this place. So we move our pointer to the next index. When we move here, we again check for the 2 adjacent flowers. As there are no flowers present adjacent to this empty place, we can plant a flower in this place. So we will plant a flower and also keep a count of it that we have planted 1 flower at this place. We move ahead with the same concept, checking every 2 adjacent edges of a particular empty space and move ahead till we reach the end of the array. Now in this case, we know that the maximum of only 1 flower can be planted with this particular combination. If n is greater than that, we cannot plant these many flowers, so we will return false, otherwise we return true. Remember, for first position and the last position, we will be seeing only 1 adjacent position and not the 2 position. So let's see how we can code this approach. So as discussed, we will have a count variable and we'll start looping from first position till the end of the array. So only if the flower place is empty, we need to perform these logics. We need to find 2 values, the previous and the next value. And only if the 2 values are 0, we'll plant flower and increment the count. Now the previous value is equals to 0 if I equals to 0, or the previous value, that is I minus 1, is 0. In both these cases the value will be 0, otherwise it will be 1. Similarly, if in the case of last value or the next value is 0, then it is 0, otherwise it is 1. At the end, we just need to return if the count is greater than or equals to n. When we run this code, it gives the right output. Let's test this for second input as well. So it is giving correct result. Let's submit this code. So the code got submitted successfully. We can further optimize this problem, and rather than going till the end to find if the count is greater than or equals to n, we can just return it directly from here. If the count is greater than or equals to n, then we simply return true, otherwise at the end we return false. So we can submit this code also. So this also got submitted. The time complexity of both the approaches is O of n and the space complexity is O of 1. Thanks for watching the video. See you in the next one.